Hello everyone, welcome to the Russellville Creek. I'm here to talk to you today about Kirchhoff's current law. So, to properly understand KCL, we need to first properly understand what current is. And what a better example than looking at water current, which, just like electrical current, which is charge over time, water current is water flow over time. So, as water current approaches a junction, it splits off into two different directions. And depending on how much blockage is in each direction, will depend on how much water flow there is, just like how resistors in an electrical circuit work. But the most important thing to understand KCL is what comes in at the top of a junction has to equal what comes out because of conservation of water or conservation of electrical charge.
So, to relate this concept back to electrical circuits, I've drawn up a parallel circuit multisim, which I'm using multisim because I don't actually own a proper circuit, but this is good enough. So, following what we talked about KCL, with this simple circuit here, we've got 12 volts inputted with different resistance in each strand coming out of the junction. We should know that the current coming into the top of the junction should equal the current coming out, which means while it is different resistance, these two strands should add up together if KCL is true. So let's run this, in which the inputting current is 3.6 amps, and this one has the greater resistance, so it should have less current, in which it has 1.2 amps, and this one has 2.4 amps, and 1.2 plus 2.4 is 3.6, and yeah, that is KCL right there. So to pop it into proper notation, that is IS minus I1 minus I2 equals 0, because that is the conservation of charge in an electrical circuit. So the main purpose of KCL is it helps us understand and analyze circuits. It shows us the way current behaves in an electrical circuit, and it really helps us solve complicated circuits. For example, nodal analysis. Nodal analysis requires an understanding of KCL, as we need to look at the individual currents coming in and out of each node. So in summary, KCL is built upon the conservation of energy, conservation of charge in an electrical circuit, in which it helps us break down and solve unknown values or other problems to do with electrical circuits. Thank you for watching.